Hello IB, let's have a look at 22G, sampling with and without replacement. So we've been talking a lot about that because if we sample with replacement, that means two events will be independent, they're not affecting each other. If we're sampling without replacement, that means we've got a dependent event, so the probabilities will be changed depending on what happens in the first draw or the first part of the sampling. So let's look at some of the questions from the section on this, and we're going to usually use trees to help us out with them. So we've got, in question 1, 2 marbles are drawn in succession from a box containing 2 purple and 5 green marbles. Determine the probability that the 2 marbles are different colours. So what we're trying to find here, and this is a good habit to get to in your exams, highlight the key things. We want 2 marbles and we're after different colours. That's the goal of this question. In the first case, it's being replaced. So if you think of your tree, you're getting marbles being drawn, purple, green. If we've got 7 marbles and we've got 2 purple, so 2 out of 7 and 5 out of 7, where we're starting with. Now when we draw the second marble, if they're being replaced, purple, green, our probabilities stay the same. 5 out of 7 for green, and the same here. Purple, oh that's a P. Green, 2 out of 7, 5 out of 7. So then if we want the probability that the 2 marbles are different colours, so we want to go purple then green, that option, and then green then purple, that option. So our probability is going to be, I might do this underneath, the probability of purple and green, or green and purple, is going to be 2 over 7 times 5 on 7 plus 5 over 7 times 2 over 7. So remember, we're multiplying along the branches here, but then when we want to go vertically, we want to add the probabilities because we want those 2. 2 5s are 10, so we've got 20 out of 49. In the second part, the only difference here is that the first is not replaced. So we start off the tree in the same manner, purple and green, 2 on 7 and 5 on 7. But now, if we've already taken a purple out, purple, green, let's just draw this in, purple, green. So now 1 purple's already gone, so that means we only have 1 purple left, and we now only have 6 marbles left because the first one isn't replaced. No greens have been taken at this point, so we now have 5 out of 6, and we see again that these add up to 1. Each little branch is going to add up to 1. In this case, we've taken a green out once we get to this point, so we still have 2 purple left, but we only have 6 marbles. Now we've taken a green, so we've only got 4 left out of the 6 marbles, and again they add up to 1. Sometimes it's not worth simplifying this down to 1/3 and 2/3 because up here we can't simplify and we want to be able to add the fractions together. So now the probability of getting purple and green, or green and purple, is going to be equal to, remember we're after this option, which is our purple-green, or this option, which is our green-purple. So we've got 2 over 7 times 5 over 6 plus 5 over 7 times 4 over 6. Alright. Oh, no, it's not 4 over 6. Mistake. Oh, where's my eraser gone? That's it. So sorry about that. We're doing 5 over 7 times 2 over 6. So what does that come to? We've got 2 5s are 10. 20 over 6 7s are 42. So you should be able to draw this without a calculator. So at this point you can simplify down. So we could go, what are we doing there? 10 over 21 for our probability. In this next one here, we've got a die and we've got 4 faces showing on the die. 4 faces that show A on the die. So we've got 1, 2 underneath and on the back side. 2 faces that are B. Jar A contains 3 red and 2 green marbles. So we've got A has 2 faces and B, oh no, A has 4 faces and B's got the 2 faces. Jar A, we've got that many tickets. Jar B, we've got that tickets. Once the jar selected, 2 tickets. Once the jar is selected, 2 tickets are randomly selected from it without replacement. Alright, so we want to set up our tree. So the first job is that we need to throw our die to work out which jar we're going to choose, and our die will tell us either A or B. Then, once we've got our jar, then the options are red and green in both jars. Alright, probabilities. Chance of getting A, we've got 4 faces out of 6. So we could simplify this one because there's no other option, so you could turn that to 2 out of 3. And jar B is only got 2 faces on the die, so that's 1/3. So that could make it simpler. In jar A, we've got 3 red tickets and 2 green. So we've got 3 out of 5, 2 out of 5. And in jar B, we've got 3 and 7, 10 tickets. 3 out of 10 are red, 7 out of 10 are green. And in the first part, if you want to go both green, that means you're looking at jar, oh, 2 tickets, we've got to go again. Sorry. Red and green. And we're without replacement, so we need to keep that in mind for when we do the probabilities. Red, green. So doing the tree is the slowest part, but the most important part. So red, green, and going through and putting your probabilities on. So now if we've already drawn out a red, we've only got 2 left and 4 in the jar because we're not replacing. Now we've got 2 green that are still in the jar and only 4. In this case, we've taken a green, so we've got 3 reds out of 4, and we've taken one of the greens, so we've now only got 1 left out of 4. Gets squashy. In this case, we've taken a red, so we now only have 2 out of 9 left. And here we still have our 3 out of, oh no we don't, we have our 7 out of 9. Let me just do that again so it's neater. 7 out of 9 green. Down here we don't have any reds taken yet, so we've still got 3 out of 9. One of the greens is gone, so we're 6 out of 9. Alright, so now that's drawn up. If we want both green, we've got to go green, green, which is that option. Green, green, which is down this option. So get your tree drawn up, and then it makes it easy to find those. I'll leave you to work that one out. This last one, which what we won't do now, but just to give you some, get you thinking about it, ready for class time. If you've got 7 yellow and N blue markers, 2 markers are selected at random without replacement. So we've got without replacement, so it's dependent events. The probability that both markers are yellow is this, how many blue markers. So basically, if you think about how do we go about this, same strategy, set up your tree, but in this case we don't have a number for our blue markers, we have an N. So all the way through your tree you're going to have an N somewhere in here, but we now know that the probability of getting both markers being yellow is 3 on 13, so you'll need to set up a multiplication of probabilities that will equal that and then solve. Anyway, have a go at setting that up and we'll talk about it in class. Thanks for listening and have a good day.